So we're going to begin by walking through the frequently made mistakes for assignment 1B. A couple things to note off the bat. Please make sure that you run the unit tests. There were a number of problems here that should have been flagged by running the unit tests, and they will give you lots of feedback on things that might otherwise fall between the cracks. Of course, if you have any questions about any of the tests, please don't hesitate to ask. Also, make sure that you submit your assignment on time. I'd say about 10 people didn't submit the assignment on time, and I got some of those reviewed later, but it really makes things more complicated because it takes a fair amount of time to review everything by hand. So if you can get them on time, it makes my life a lot easier to give you back feedback. So let's start by talking about some problems that were left over from assignment number 1. Make sure you address these in the final version that you're going to submit. We'll talk about that in just a second. So first and foremost, make sure that you use a more efficient approach to implementing the index of method. In particular, you really don't want to have complicated expressions inside the for loop. We talked about this last class. There's a number of reasons for not wanting this. One of the reasons is that it has extra loops through the code or extra checks through the code, and you don't want to have extra checks in an inner loop if you can possibly avoid it. Number 2, this type of a class is intended to be a class that's used for many other things that layer on top of it. So making infrastructure code as efficient as possible is a win, even if you maybe do a little bit of space for time trade-offs. So this would be a good example of a time-space trade-off. And the way I recommend doing this is by having 2 loops, one loop that handles the case where the parameter is null, and the other loop that handles the case where the parameter is non-null. So that's a great example of a time-space trade-off. You got a little bit more code, so it's slightly larger use of space, but the runtime should be faster. And then yet another reason for this is that if you were to take a look at the implementation of index of in Java, you'd see that they do the same trick. So it's a good habit to get into to follow good models like the Java implementations of stuff, because they obviously have been doing this for a very long time. Some other things that's kind of along the same lines, although it's a slight variation. For one of the loops, the loop where you know that the parameter O is non-null, you don't need to check whether m element data sub I is equal to null. You do not need to make that check. All you need to do is just swap the order of the comparison so that you say O dot equals, and then you pass in m element data sub I. Because we know at that point that O cannot be null, so therefore you never have to worry about having an index through a method called through a null pointer. So that's the reason why someone was making this check in the first place, of course, but this check is completely and totally unnecessary. There is no need to have this check. So just a good habit to get into is write code that is as efficient as possible while still being legible and coherent. I think this would be a good example where that would be the case. All right, let's now move on and talk about some other issues that were kind of left over from before. Please make sure you go back and fix problems from earlier assignments, because that's what you'll be graded on. Ultimately, is the entire assignment 1A and assignment 1B will be used to calculate your grade. So please don't sort of do a half-baked job of it. This particular code is way too complicated. This is the add-all code. What you should do is refactor a lot of this complicated logic into the ensure capacity internal method. And so sort of after you've figured out you don't have a null array, and after you figured out that you need to basically take the contents of the array and add it to the current size of this, what you need to do is use the ensure capacity internal method to make sure that the capacity is big enough to hold the contents of both of those things. And then at that point, you'll do the copy. But there's no need to do all this other extra work here and allocate a new object, blah, blah, blah. That should be pushed inside of ensure capacity internal. That's why it's there. So make sure you think carefully about how that works and refactor it to avoid unnecessarily duplicated code. Yet another issue, please don't use loops. There's a handful of places where you need a loop. You need a loop for replace all, most likely, unless you do a clever approach that uses Java streams, which you're welcome to do, but it's pretty advanced. You also need a loop for the for each method, but here in remove, you don't need to use a loop. Instead, you want to use the system.arrayCopy method. And there's a bunch of reasons for that. Number 1, using arrayCopy judiciously means less chances to have off by 1 errors, which are the bane of index-based for loops. And number 2, it's most likely that array copy could be optimized in some implementations to be faster than you could do if you did it a loop by hand. So just some things that are worth thinking about in order to make your code more concise, less error prone, and most likely more efficient as well. Here was a very curious mistake. I'm not quite sure how this happened, but the person is indexing into melement data to get the old value and then calling range check. Obviously, if the element's index is beyond the range, then you've already gotten a null pointer exception or something else horrible at that point, whatever the exception is for trying to exceed the array bounds. And you instead want to call range check. Much cleaner, much safer. That way you know what you're getting. You're getting the index out of bounds exception and so on, and not just sort of arbitrarily having your code blow up in mysterious ways. So make sure that you do the range check before you index into the array. That's exactly the reason why it's defined to be that way. Here is some super duper complicated code trying to implement the add method. I have absolutely no idea whether this code is correct or not, but it just is way more trouble than it's worth. Most of this code needs to be factored into the ensure capacity internal method if it's not already done that way. And add should simply call ensure capacity internal, indicating how far we want to go, and then make sure that the size is right, and then add the element at the end. So this is way, way too complicated. It shouldn't be done this way. You need to refactor it to make it cleaner. A couple people had problems with replace all. Replace all is one of the few places where an index-based for loop is a reasonable solution. There are other much more clever ways of doing it using Java streams, perhaps too clever in some ways because they allocate extra memory, but it's definitely very clever. This approach, however, is not correct. So whether it's clever or not is beside the point. It's simply applying the operator on every element in the array. However, it's not updating the contents of the underlying melement data array or mdata element array or whatever it's called, melement data array, that's it. And so as a result, you're not going to have the side effects that you would like from replace all because you're not actually replacing anything. You're just applying something. So it's almost like a for each method, but it has no particular purpose. So don't do this. You probably don't want to use a for each loop. You probably want to use an index-based for loop, or if you really want to be clever, you could do the approach that uses Java streams. Although, as I said, that has some extra overhead. Now let's take a look at for each. This is also something I went over in the last class, so I'm a little perplexed as to why it's still a problem in people's code. Basically, if you read the specification, it says it's pretty clear that it wants a for each loop. And in the next frequently made mistake for each, I'll give you a pointer to go to look to find out how to do this. But you don't want to be using iterators here. Secondly, down here, once again, we don't want to be doing this. Instead, you want to use a for each loop. And what I recommend you do is take a look at the video, whose link is in the comment here. That's one of the videos that I have on my website that talks about good functional programming in Java, talking about the consumer functional interface. And if you take a look at the time frame at about 2 minutes and 58 seconds, it'll explain to you how to do this kind of a loop. It's really very clever and very clean. And so it's a good thing to know about, which is why I put it in as part of the assignment. Let's see, some other problems here. You don't need to be using object. You can be using E. And once you use object instead of E, then you can go ahead and get rid of the cast. So try to avoid cast whenever possible. I realize it's not always possible when you're doing stuff with Java generics in the fashion we're doing here, but it's good to do it when you can. And then down here, this code is broken in all kinds of different ways. You don't want to be doing stream on element data. That is definitely not what you want to be doing here. That'll cause all kinds of problems. Instead, you want to be using the .stream method, which will use the splitterator. And you also don't want to use map here because the value here should already be typed with type E, so there's no need to cast it. And finally, please make sure you use a method reference as opposed to a Lambda expression. As we've talked about a number of times in earlier parts of the course, method references are much preferable to Lambda expressions when they do the same thing, because method references make it more clear what's going on at a glance. All right, so that was all stuff that was kind of left over from assignment 1A. So please make sure you go back and fix any problems that I identified with assignment 1A. Please go back and look at the comments for assignment 1A and make sure you address them for the final submission that you will have for assignment 1B, which will include 1A as well. Let's now talk about ways to do splitterator, or perhaps a better way to think of it is ways not to do splitterator. So this code is way, way, way too complicated. I'm not quite sure what it's doing, but it's very complicated and not what we want at all. All you need to do is make a new instance of array splitterator, which is the class that you were supposed to implement, and then pass in the appropriate parameters to it. And you can either take the parameters that I gave you out of the box, or a couple of intrepid people added their own constructor that took parameters in a different way, which is perfectly fine. But whatever the case is, what you're doing here is not what's required. So please don't do that. Likewise, here's an example that's a little closer because it actually makes an instance of array splitterator. But for some reason, I was unable to derive from looking at the comments because it wasn't commented. It was unclear why a -1 was being passed as the third parameter. If you take a look at how splitterator works, it starts by splitting the entire range from the beginning to 1 past the end. So make sure you think carefully about what it means to be 1 past the end, and that will help you decide what parameter to pass in as the third parameter here. Okay, now let's start taking a look at, these are actually a few more things that are kind of left over from assignment 1A. I take it back, we haven't gotten through all that yet. A good example would be the iterator implementation. So if you use the call to has next, which is what's done here, that will check to see if things are in bounds, and that's fine. But if you do that, you don't need to make a call to get, because get will also check to see if something is in bounds. And that's kind of the belt and suspenders mistake. You don't want to do things that are have gratuitous overhead or gratuitously expensive if you can do things that are ensured to work properly, but don't give you gratuitous overhead. So please stay away from gratuitous overhead. That would be an example of something that has too much checking. So either use get and catch the exception if the index is out of range, or you could also call has next and then use the unchecked to array method just to get the reference to the array. Something else that's probably worth thinking about here, arguably, although I could see reasonable people disagreeing, you probably want to refactor this code so that updating the current pos and last index occurs after you know whether get has thrown an exception. This particular method should be fine because has next is checking that. But in general, you probably want to only update the state of your object after you know an exception won't be thrown. That's just kind of good practice to get into from exception safety guarantees, which Java admittedly is less obsessed about than C++, but it's still a good habit to get into. Here's remove. This was the whole implementation of remove. Obviously, this code is lacking a bunch of things. In particular, it doesn't really update the various fields appropriately once something's removed. So please make sure you follow the specification and get all the different pieces to work together properly. Similar problem here. Don't inline the calls to array copy inside of remove. That's already been done quite nicely and hopefully optimally with all the appropriate checks and optimizations and so on in the remove method that's part of unsynchronized array. So call that method instead. This is a classic example of the don't repeat yourself principle, which it's kind of funny because the index of method we talked about before is kind of an example of, it's kind of a counter example to don't repeat yourself, because we're kind of repeating ourselves a little bit, but we're doing it for good reason because we want the code to run fast. This code is not really running any faster. It's just doing things in an incomplete way that will be hard to maintain. Now let's turn our attention to the splitterator. So some people got this perfectly fine, good job in that case. Other people kind of struggled with it for various reasons. A couple things to note: array is a generic type, so don't use a naked type. Make sure you put the right thing in there. I think it's pretty obvious what needs to go in there, given that it's parameterized by type E, but I want you to get in the habit of doing that. And your compiler will probably yell at you or give you a warning if you don't have the types correct. Another thing, you don't need to do atomic integer. I'm not sure what atomic integer is doing here, but remember that splitterators are never called in a way that would lead to race conditions. They're always called in one thread of control, And so as a result, there should be no problems with weird race conditions or atomicity and so on and so forth. So you don't need to have atomic operations. Just a good old int will do perfectly well. Another thing to keep in mind, you don't need to make a copy of the unsynchronized array. In fact, I think that'll probably fail the test. But whether it fails the test or not, you don't need an extra copy. Just basically use a reference to the unsynchronized array that's passed as a parameter to the array split iterator, and then simply update those two indices, the one that's kind of the current index and the end of the range. Those are the things you need to be updating, which is much faster and less memory consumptive than using copies of the array. People were also getting confused as to what parameters to pass to accept. This, I don't know how this code could even possibly compile. It certainly shouldn't be passing the unit test. So if you're running into weird problems, by all means, come to Alpha Hours and make sure you ask questions. But the point here is you don't want to accept the array. You want to accept the next element in the array. And that, of course, is what's found by doing some clever things with the unchecked toArray helper method that returns a reference to the underlying array. And we'll talk about why you do that in a second. Here's an example of why you should do this. So this code uses the get method. Once again, we don't need to use the get method. The try advance method should be checking to see that the value is in range and blowing up if it's not. But if it is in range, we want to use the unchecked toArray method to get the underlying, a reference to the underlying array without requiring a range check each time. Again, these are meant to be infrastructure classes. It's a good idea to make them as fast as you possibly can. And we also don't want to be using this get an increment thing. That's the atomic integer that we don't want to use either. A couple other things. A lot of people had problems with this, and they would say, oh gosh, my unit tests run forever. Well, there's a good reason for that. You need to make sure that you reset the value of the origin index in this particular case. So before you create the new array split iterator, at some point, you need to make sure that you update origin index. And that way it'll cover the right-hand side of the split array, and then you'll create an array split iterator to cover the left-hand side. So make sure you think those cases through carefully. I'm not sure what this person was trying to do. It looks like they were trying to avoid, like minus carries with right shifting or something like that. Right shifting by 1 is the same as dividing by 2. You probably don't need to do that anymore. Modern Java compilers will do that optimization on your behalf. But even if you decide to use that particular thing, the way it works is it won't shift in the sign bit. So you don't have to AND it with basically -1 or whatever tilde 1 is. I guess that's the inverse of the bits or something. But at any rate, you don't need to do that. Let's see. This couple people had really, really convoluted implementations of try-split. Try-split is a very simple method. It's got a little bit of tricky logic in it to figure out where the halfway point is and whether you have any elements left to even split in the first place. But once you do some very basic math, then you're almost home free. You just have like 2 or 3 lines of code to do. So I don't know what's going on here, but this is way, way, way too complicated here. We don't need to do any of this stuff. I'm not really sure what's going on. Once again, this code is not commented, so I had no idea what the person was doing, but wow, it's definitely wrong. And then down here, there's another implementation of try-split that's also way too complicated. So there's no need to make new array split iterators, except for the one that you need to make to cover the left-hand side. There's no need to make new synchronized arrays. There's no need to do array copies. Those are all wildly inefficient. I'm not even sure if it's correct, but it's definitely not what you need to do. You just need to make one array split iterator that'll cover the left-hand side, and then you update the index to point to the midpoint or one past the midpoint or however you do the computation to get it right. And that'll then cover the right-hand side. So all this additional logic is just extra work. And I don't know whether it's right or wrong, but it's definitely, I don't know whether it's semantically correct or not, but it's definitely way more than you need to add. Okay, so those were the things that I found that needed to be fixed. There may have been a few other things that I missed, but this will certainly give you a good head start. And make sure again that you submit your programs on time so I can give you comments. I should also hasten to add something else too. I posted the new link to office hours in Piazza. I had sent out the wrong link before. I sent out a different link in my email originally. I'm sorry about that. The one that I posted to Piazza the other day is the correct one. So please use that one if you'd like to join office hours. And if you have times, if you can't make it during my office hours, please let me know and I'll be happy to chat with you other times.